Hello students, in this video what I'm going to do is I am going to talk about what exactly is a perfect square and then eventually talking about how to complete a square. So let's try to answer the question of what is a perfect square. So a perfect square is something like this. I have 36, I have 36. This is a perfect square because I recognize that 6 quantity squared is equal to 36. I also recognize that 49 is a perfect square because 7 squared gives me 49. So we can actually go and rewrite this in reverse. So for instance, I can say 5 quantity squared. This is a perfect square because 5 times 5 multiplied by itself is 25. And actually, I can do this with almost anything. I can say that this is a perfect square, right? I can say that this is a perfect square. I can also say that this is a perfect square. Seems getting a little more abstract, right? So we start off with something, that you were introduced to probably back in grade school, where you have these integer values, okay, that are actual perfect squares. Well, we're broadening our definition for what makes something a perfect square. Something that's a perfect square is simply something that multiplies to itself, and the result being it will then be a perfect square. So if we extend that definition, then all of these things are going to be perfect square. So what will this look like in order for this to be a perfect square? Well, on the other side, what we'll have to do is we'll have to FOIL. If we FOIL a plus b quantity square, if we FOIL a plus b times a plus b, we'll actually end up with a squared plus 2ab plus b squared. Similarly, this is also a perfect square. So what we're doing is we're multiplying a minus b with a minus b, and that gives us a squared minus 2ab plus b squared. So all of these are going to be perfect square. So the purpose of this video is actually to show you how to complete the square, okay? And this next part, it will require you to have a little bit of algebraic understanding. So I understand that these two things, okay, a squared plus 2ab plus b squared is equivalent to a plus b quantity squared. This is also equivalent to a minus b quantity squared. So these things are perfect squares. So suppose you were given a question in the form of a quadratic equation. So you have x squared plus 6x plus k. We need to figure out what number to add here to make this a perfect square. Looking at this right now, okay, which structure do you think this equation would fall under if we were trying to turn this thing into a perfect square? If you're saying to yourself that it actually falls into the first category, if it falls into the first line right here, you're absolutely right, because how we can tell which line it actually falls into has to do with this number right there. And because that is positive, okay, we recognize the middle term there has to be positive. All right, with that said, let's try to figure out what k is. So recognizing that it falls into the classification of that first line there, then that means x squared plus 6x plus k should resemble this equation here. And what we are really set out to do then, in other words, is to not just solve for what k is, but to solve for what b squared is, okay? So recognizing that all these things, they sort of like pair up. Can you see that, right? So thereby making a equal to what value? If a squared is equal to x squared, then a is x. And if 2ab is equal to 6x, then we got to figure out what b is, right? Wait a minute, isn't a equal to x? So I can say 2 times x times b is equal to 6x. But wait a minute, isn't that what, aren't there x's on both sides? So that means I have 2b is equal to 6, or b must equal to 3. If b is equal to 3, and we're looking for what k is, right, and k is equal to b squared, right, k is equal to b squared, then therefore k must equal to b. I mean, must equal to 9. So k is equal to 9. In other words, this then translates into x plus 3 quantity squared, because again, this translates into a plus b quantity squared, right? So k is equal to 9. Let's do another example. So suppose I give you another quadratic equation, and I have x squared minus 10x plus k. And again, it's the same kind of process. I want you to complete the square by figuring out what k is, and also write out what is that perfect square. Okay? So upon inspection here, what you should see is that this equation, this quadratic equation, falls along the same pattern as the second equation from before, right? A squared minus 2ab plus b squared, because we're looking at the middle coefficient here. So it looks like a squared minus 2ab plus b squared. We're trying to make this equation look like this. Okay? So with that said, let's take a look. I know that a corresponds with x squared, so therefore a must equal to x. And I know that 2ab corresponds with 10x, so therefore 2a, which is x, times b, I don't know what b is equal to 10x. So recognizing that this statement has to be true, b therefore must equal to 5. And therefore k must equal to b squared, right? So that k must equal to 25. So k is 25. What is the perfect square expressed as a binomial quantity squared? Well, a, so this is equivalent to, again, a minus b quantity squared, yes? So therefore, the binomial squared will be x minus 5 quantity squared. Let's try to do this one more time. This time, let's try to do this entirely on your own. So I have x squared, let's say minus x squared minus 16x plus k. So let's try to figure out what k is and what is this expressed as a perfect square. So go ahead, pause the video. Hopefully you guys had some time to think about this. So again, recognizing that this is the only number that we should be scrutinizing over. The 16 should equal to 2b, right? Because that's what it all boils down to. So we're going to take the middle coefficient there, and we're going to half it. And then k is just going to be 16 over 2 quantity squared. Okay? Or in other words, k is equal to 64. So again, whenever we're figuring out what k is, in summary, right, we're always taking the middle coefficient, half it, and square it. So the binomial squared is going to turn into x minus, because I have a minus here, x minus b, right? Because it's a minus b, so that's x minus 8 quantity squared. Let's try to do this one more time. So suppose I have x squared plus 5x. And again, I'm trying to figure out what k is. And what is this expressed as a perfect square? Go ahead and pause the video to see if you can figure this out. Hopefully you guys had some time to think about this. Again, this falls in the same classification as a squared plus 2ab plus b squared is equal to a plus b quantity squared. So again, I want to take that middle coefficient here. And what I'm going to do, as it turns out, b is always going to equal to that middle number divided by 2. So immediately I know that this is going to be x plus 5 halves quantity squared. What exactly is k? K is always going to be that middle number divided by 2 quantity squared. So what's k going to be? K is going to be 25 fourths. So again, k is 25 fourths. And the perfect square is x plus 5 halves squared. Let's do this one more time. Last one. So suppose I have x squared minus 9x, and again we're trying to figure out what is k, as well as what is the binomial quantity squared. Pause the video to see if you can figure this out. So hopefully by now we should have a little more fluency. B, as it turns out, is just 9 halves. This is simply x minus 9 over 2 quantity squared, and k is simply 9 over 2 quantity squared, or 81 fourths.